Hello.
Hello, Professor.
How you doing?
All right.
Hi guys, how you doing? All right, let's see who we got so far.
Good evening.
Jambria, Dominique,
Hi, Professor.
how you doing? Justine. And
Hi.
hello. All right, I got all you guys at least. Hannah. Hannah, I got your attendance. Joshua. Sarah. Gabrielle. Hello. All right, I got all your guys' attendance. Gabrielle, Teresa, Shambria, Dominique, Justine, Hannah, Joshua, and Sarah. All right, does anybody have any questions about anything associated with the logic stuff?
As of now, I don't have any.
Because this module still has some time left on it, so that means it's due probably this week, the exam. And, you know, I mean, I'm gonna start the next one. Otherwise, but if anybody has a question, you know, we can go over it again. If you want me to, so you just let me know what you would like to talk about. And don't forget all of these things on the syllabus here, you know, that you can use to, you know, relearn or re-see how to do this stuff. Because, you know, it does link you directly to the part of the book and all that.
Right.
Not that that's really that hard to find in the first place, but nonetheless.
This is the actual help.
And then there's the review. So we could look at that a little bit, I guess. But, you know, these are all the different things that we did. Doesn't have anything here. Great. So that's not very helpful. Now, don't forget also, of course, you know, you do need a whiteboard. I did not see a lot of your guys' whiteboards last time. I can't let you do that again. So, you know, this is pretty clear on here. And I do need to be able to see you on actual camera. So not the way I have it right now. Like, this is not me seeing you. You know, you don't have to have it set up like that right now. But
Yeah,
I
I was actually about to ask you a question. Is this like seeming like a good setup where like I'm trying to make sure my hands are visible, you know?
it's yeah, that should be
Is it
fine.
hard? Like, is this good?
Yeah, that should be fine. As long
Okay.
as you just have to leave the board right there, you know?
Yeah,
It
yeah, I'll
doesn't- it
have it
doesn't-
right on with me.
Yeah, it should be fine. So
For
then the but if anybody has any questions, just let me know and we can talk about it. Otherwise, I guess we'll go on to geometry. Does anybody have any questions?
Oh, everything isn't due till the 29th, correct?
The exam, I think, is due earlier than that. So the things probably should be due earlier than that. Again, all you have to do is really just click on all assignments here. And then when you click on all assignments, it should open up the window with all of the assignment dates.
The due dates.
So 17th is here. This one's, no, 29th.
Okay, cool.
Okay. But the other test is due like in a week or some nonsense. So, you know.
Yeah,
that-
because this
that-
one seemed longer than like the last one, like last week.
Yeah, well, this one's like 6 sections, so that's why I made it longer, because I had to
Okay,
make
cool.
something longer. You know what I mean?
Thanks.
Um. All right, so, I mean, I think you know what a point is. A point is represented by a dot. A line is, extends, indefinitely in 2 directions. That's a good way to say it. Has no width and is determined by 2 distinct points. A plane is represented by a flat surface and is determined by 3 points, not all on the same line. Does that make sense?
Yeah.
Like if I put 3 points down somewhere, it would automatically define some 2-dimensional plane. And then like a 1-dimensional object. That's more like a line. And then if you said 0-dimensional, I guess that would be like a point. But a line, 2 points determine a line. 1 point is obviously needed for a point. 3 points are needed to determine a plane. Array has a starting point and it extends indefinitely in one direction. So array would be something like, first of all, we should say how we name these things also.
Alright.
So if I said this was like A, B here, we would call this A, B, ray, or sometimes people will write it like this also. Actually, let's just write it the first way. So then, and then a line, if I said this was A and this was B, this would be indicated more with something on top that actually looks like a line. Sometimes array is also referred to as a half line. Because it's really only half the line. It only goes in one direction. So like ray AB would be this, ray BA would be different. It's the one going in the other direction then. Okay. A line segment includes a starting point and an ending point and all points between them. So for instance, if I drew this from here to here, that would be AB line segment. Okay, any question with any of this? All right. 2 lines are parallel if they are in the same plane, but never intersect. Lines that are not parallel in the same plane are called skew. Excuse me, lines not in the same plane are called skew. I think everybody knows what he means by parallel lines, but do you know what he's saying with this, what a skew line is?
Is that when it intersects?
No, No. So another way, so he says his definition of skew line is lines not in the same plane.
Oh,
That to me is kind of a confusing way to say this. So let's instead try and say it another way. So these are, another way to say this is two non-intersecting non-parallel lines. So skew lines are two lines which don't intersect and are not parallel. Does that make any sense? How can you have two lines which are not intersecting and are not parallel? So parallel, first of all, means
side by side.
two lines in the same plane that don't intersect. So if I wanted to draw two parallel lines, I think you know what that means. Like we would say AB. And then we would draw this symbol is parallel to CD. This is parallel to. Okay.
Yep.
So. So first of all, skew lines cannot be in the same plane. I can't even draw what this is saying in the same plane, okay? So these have to be in two different planes. In other words, we need to think about this more like three-dimensionally. Does that make sense?
hmm
Can anybody give me an example of what this would be? What's an example of two lines that are not intersecting, that are not parallel?
A side of a cube?
What do you mean?
Like if you have a cube, well,
Yeah.
it would intersect, right? If it goes,
Well, I don't know what that's why I'm a little confused with what you're saying. So like if you have a side of a cube,
yeah, so you have two corners, one corner, that corner.
so side of a cube. So side of a cube would be like something like this,
Yeah,
okay? But I'm saying two lines that
So
don't
it
intersect.
could it be one going vertical, one's going horizontal? Is that,
Yeah, that would work, okay? So like something like maybe if I have a line going this way and a line going that way, does that make sense?
Yeah,
Like these lines are not parallel, but they're not intersecting either. Does that make sense?
and they're not on the same plane, right?
they're not touching.
They're not on the same plane, no. They're not touching, no. They'll never touch those two lines, I'm saying.
Okay,
Like this one going straight up and down, you see?
Yeah,
And this one going directly like left and right.
yeah.
So they never really touch. I mean, we can even draw another one that let's say it goes, like from there to into the cube somewhere over here. And it went like that a ways and down all the way below this. So this like went down here somewhere. And then this went actually in front of this. Does that make sense?
Yeah,
None of these lines would intersect. These things are all called skew. Does that make sense?
yeah.
All right. An angle is made up of two rays with a common endpoint called a vertex. So, you know, an angle is really just like sort of like an opening. So we take two rays and then we start saying that this is some angle here. So, and then this angle we say has some sort of measure associated with it. The measure of angle A, you know, sometimes people will write something, you know, whatever. Let's say this is like 45 degrees. Does that make sense?
Yeah,
Because a, you know, this is a 90-degree angle, right?
Mhm.
Or a right angle. And then these two lines are said to be, what's the word, do you know? They're not parallel, they're
Perpendicular.
perpendicular is correct. Thank you. Perpendicular. So, if I label this thing, let's say I call this A, this B, and this C, then this angle, the way we usually label them, we would start calling this something like angle ABC. Okay? You would not call this BAC, BCA, any of that stuff. You call ABC or you call it CBA. Does that make sense?
okay, yeah,
All right. So the perpendicular, also sometimes people will write this symbol. So like AB ray is perpendicular to BC ray. And the way I think about this perpendicular is like, I think it looks kind of like a wall to me, like a wall, like hitting another, like the floor. And
yeah.
like, that's perpendicular. Does that make sense?
Hmm.
Alright. Angle, so an angle is really just like an opening, some sort of opening. Okay. He says an angle was made up of two rays with a common endpoint called the vertex. Yeah, so this point right here is referred to as the vertex. Okay. Vertex is really just like the place of intersection. The measure of an angle is given in degrees, with 1 degree is 1/360th of a full rotation. So, in other words, that means that a circle if I refer to the entire measure of the whole circle right here, let's say this was the point O right here. So the angle associated with this measure right here, what's that angle? It's the total measure of an entire circle.
360.
360 is correct. So like if you thought about this a little bit, I think it's kind of easy to remember because you know that 90 degrees. So if we, oh, we just made a big circle. If I split this way and I split this way, obviously that's 90 degrees, that's 90 degrees, that's 90 degrees, that's 90 degrees. So therefore this would have to be 360 degrees. So 360 degrees, he's saying, is one full rotation or revolution. Okay, so then they'll say, so then in other words, what that means is that 1/360th of a rotation, or let's say a revolution, is 1 degree. Okay. Any question with that?
Wait, so rotation, revolution mean the same thing?
If you say a full rotation or a revolution, does that make sense?
Yeah,
Yeah.
Okay. So an angle between 0 and 90 is called acute. So that would be something like this type of opening. 90
Yeah.
and 180 is
Twos.
obtuse. An angle measuring exactly 90 degrees is a right angle, which we've already kind of talked about a little bit. An angle measuring 180 degrees is a straight angle, which I guess is really also a line. Does that make sense?
Yeah.
Yeah.
Two angles whose measures have sum of 90 degrees are called complementary. Okay. So this, you just really need to know the difference between the words with these things. I mean, we're gonna do questions associated with it in a second, but you need to know the difference between the words. So supplementary. And complementary. Does anybody know which one's which and what these mean? Don't all jump at once.
Would complementary be like how you said it was two angles that add up to 90 degrees?
That's that one. So what is the other one then?
The sum of 180.
That's correct. All right, let me see that. So this, two angles are supplementary if the sum of their measures is 180 degrees. And then two angles are complementary if the sum of their angles is 90 degrees. How can I draw a picture representing each one of these? What would the picture, what would be the best way to represent this particular statement in some sort of picture? Or this one?
Mm,
Well, the 180, you would do a straight line and then a line coming out in the middle. That would be two angles, right?
Yes. So if I drew something like this,
Yes.
right, perfect, by the way. This, then these two angles. So I don't know, let's call this one, alpha. And then let's call this one, beta. Sometimes we'll say the measure of like angle alpha plus the measure of angle beta is equal to, in this case, I guess, 180 degrees. Sometimes people also just write the angle alpha plus the angle beta equals to 180 degrees, whichever way you wanted to write it. Okay,
I have a quick question. With the purple line in the middle, like I know you said before that like when it's like a straight line across or a straight angle, it'll be 180 degrees. But how does the purple line come into play? That's what I'm kind of confused about.
the purple line is just defining what's this angle is and what this
What that
angle,
area? Okay.
because otherwise there's no real like angle. It's just the one big angle. So
Okay.
I'm not saying the whole angle. I'm saying part of it.
Oh
is
yeah, they both have to
associated-
come together to meet 180. Okay.
Yeah, it's like this one, I mean, I could associate this with numbers. But so like, let's say this is like 60 degrees and let's say this is more like 120 degrees. Does that make sense?
Yeah.
Okay. You understand now?
Yeah, now it's clear. Thank you.
Okay. So then two angles are complementary. What would the picture need to look like for this one?
like a right angle.
Like a right angle is correct. So if I draw a right angle and then I split this somewhere and then I start calling part of it one angle and part of it the other one, the sum of these two angles should give me 90 degrees. Okay?
Yep.
Any questions so far?
No.
Lines intersecting at 90 degrees are called perpendicular lines. A line intersecting a parallel line is referred to as a transversal. In other words, this line right here is called a transversal. Intersecting lines create two pair of vertical angles. Vertical angles have the equal measure. All right, let's see what he's talking about. So if you have two lines which intersect, I don't think really anybody has to really do anything to like show you this. I'll try and say something later, but like these two. This is referred to as vertical angles. So what do I mean by that? These two angles, their measures are the same, and then these two angles, their measures are the same. Okay? Does that make sense?
Yeah.
Yes.
All right. So if we drew two parallel lines, and then I cut this with some sort of transversal. Then there's a couple of things we can say. First of all, there's a bunch of like vertical angles. Like this thing and this thing are definitely vertical. Does that make sense?
Yeah.
Actually, let me copy this first. So I can just keep drawing it. So like this guy here and this guy, that one's vertical with each other. And this one, those have to be the same also. Does that make sense?
Yeah.
All right. So now if we look and we start asking ourselves, like if these two things are also parallel to each other, like what does that mean? Like this angle here and this angle here, I don't think anybody needs to really prove anything to you. Like those have to be the same if these two are parallel. Does that make sense?
Yeah.
All right. So then this angle here is the same as this one. And that one's also then the same because those two are vertical. And then this angle would correspond to this one over here and that one. Okay, so if I name all these angles, 1, 2, 3, 4, 5, 6, 7, 8, we say that like one and 3 are corresponding, 2 and 4 are corresponding, 5 and 6, excuse me, 5 and 7 are corresponding, and then 6 and 8 are corresponding. Vertical angles, 1 and 6 are vertical, 2 and 5 are vertical, 3 and 8 are vertical, 4 and 7 are vertical. Does that make sense?
Yeah.
Does everybody understand why these angles would have the same measures? Like 2 and 4?
Yeah.
So the ones that are all equal to each other, like angle 2 equals angle 4 equals angle 5 equals angle 7, And
Yeah.
then angle 1 equals angle 3 equals angle 6 equals angle 8. Any question here?
No.
So just a second. So the vertical,
Like these two angles are referred to as vertical to each other,
okay, so
but
that,
so are these.
yes. So, the top and the bottom are verticals to each other, and then the sides are vertical to each other, right? And then,
Yeah, well, if there are two intersecting lines,
so let's say 1 and 6 and 2 and 5, right?
that's what I wrote right here.
Yes, okay. So the correspondings are on the other side of the,
Yeah, it's like if you
line.
draw
Okay.
two parallel lines
okay,
and then I draw this through here, right? Then this guy and this guy, those are said to be corresponding.
okay. So,
Or this one and this one.
okay, just a second, Professor. So we have two parallel lines, and then the line that cuts them, the traverse, I don't know,
Transversal.
transversal, I'm sorry. That line can be at any angle, wherever it meets them, the same rule would apply, right?
That's correct, because like, just think about it. Like, if you take two lines that are going in the exact same direction, right? And then you decided to cut them somewhere. I mean, does it really matter where we cut them? Like this opening and this opening are gonna have to be the same, as long as I've drawn it correctly. Does that make sense?
Okay, yeah, thank you.
That opening and that opening. That opening and that opening. I mean, I could come up with a way to prove it to you, but does it make sense?
Okay, so the angle can change, but not the proportion, not the,
Not
the-
not the relationship between the two
Yes.
sizes of the openings. Does that make sense?
yes,
But
yes.
only if the original two lines,
Are parallel.
right, that's really the important part. Does that make sense?
Yes.
Okay. Anybody else have any questions with this?
No.
Vertical angles, all right. Figure shows a line passing through points A and B, Ray, so they're drawing the symbols now here. Ray, I didn't see this before, actually. Ray AB consists of point A and all points on the line to the right of A. Half line consists of only points to the right of point A. This, like, you got, I don't know. Does anybody understand the difference between these two things?
You said that the one that's not filled in is like from AB right only.
That's correct. So this is just this means like that point is not included, point A, and then point B is included. So this is referred to as a half line. The ray actually contains the point right here. Okay,
Yeah.
so that's what, anytime this dot's not filled in, it just means a point doesn't count. Line segment AB consists of two endpoints and all points in between. Yes, I agree. All right, so he says angle 1 is obtuse. That's true. Angle 2 is acute. Yeah. Angle 1 and 2 are supplementary. Agree, because they both fill out the whole line. 1 and 4 are vertical. We know what vertical and corresponding are. All right, so 3 and 6 are called alternate interior. Alternate interior. Those things are equal to each other. How could I show those two things are equal to each other? How are the alternate interior angles 3 and 6 equal to each other?
I know why they are, but I don't really know how to explain it, honestly.
You should be able to based off what we just said before with the other verticals and correspondings. They're not vertical. Close, but no. What does 6 correspond to?
2.
2. 6 and 2 are the same. Is that right?
Mm-hmm.
Teresa, was that you?
No, that was
It
me.
was me that said 3, but,
The 2 and 6 are corresponding. You got me,
Yeah.
Teresa?
yes. Yes, I
Alright.
got you.
Alright, 2 and 3 are vertical. Is that correct?
Yeah.
Uh-huh.
Yes.
So that's how. Does that make sense?
Mm-hmm.
Right? James?
Yeah.
I think you could do that. Alright, alternate exterior angles. 2 and 7. 2 and 7. Okay, well, 7 is vertical to 6 and 6 corresponds to 2. So therefore, these things have to be equal also. Is that correct?
Yep.
These things, though, this one and this one, those are referred to as alternate exterior angles. Alright. 3 and 5 are on the same side of the transversal and are supplementary. Okay, how can I show this one? Three and 5 are supplementary. They want us to show.
Are you asking like what's another 2
How can
angles that
we-
also would be the same?
No, I'm asking, how is this true? Like he says that they're supplementary. How does he know they're supplementary? Or she?
Because they're across from each other.
Well, they're saying that if they are, then that's true, they're going to be, but that's not how, like, telling me why or not. Does that make sense?
Isn't that, like
Because
proving it?
180.
They're gonna
Yeah.
have to 180 is correct, but how do we? Is there any way we can say that? I think there is. So let's see if we can say anything. Alright.
is it
Well,
because they're like both straight lines and you have like the transversal going across and it kind of like adds that like third part, like how it was before when you described the definition of supplementary angles?
I mean, you can kind of say that because it's like if I take this part here and I just slid it over to there. Like it would have to be like a 180, but let's say it more with some of the stuff we're actually doing here. So 3 and 5, okay? So how about this? How about 3 is it corresponds to 7. Is that correct? So those two are the same, right? 5.
Corresponds to 1.
Angle 5 and angle 7 have to add up to what? What does angle 5 and angle 7 have to add up to?
180.
180, because they're on the same line, right? Now 3 corresponds to 7. Saying 3 corresponds to 7 is the same thing as saying excuse me, it's not the same thing as saying, it implies that angle 3 equals to angle 7. All right, So since angle 3 equals to angle 7, anytime I see angle 3 anywhere, I can replace it with angle 7 in terms of the measure. So then I'm gonna do that. So now I'm gonna replace this angle 7 with angle 3. And therefore that has to now also add up to 180. So therefore 5 and 3 are supplementary. Does that make sense? Guys?
Yeah.
Alright, true or false? If two lines don't intersect, they must be parallel.
True.
Yeah.
False. They're just skew lines, we said.
Oh, yeah, yeah.
If they're in the same plane, it's true. But if they're not in the same plane, it's not necessarily true.
For sure.
Alright, here's the summary of the different lines. Again, I think this was okay from before. Label array with endpoint Z, determine an appropriate name. Yeah, whatever. Label a segment whose endpoints are X and Y, determine the appropriate name. Okay. So I draw a line like this, but I don't make it keep going. And then I label them X and Y. And then I would call this XY line segment. And again, sometimes people write this also. It just depends on what the book wants to write. All right. PR union RS. What's a way we could label this? He means like, this is a circle, this is a circle, these are just points. PR union RS, what would that be? What's the same thing as saying PR union RS here? Come on. Guys,
I'm honestly trying to think like in my head about it.
what does union mean?
Or
Or, so if I say PR or RS, then it would just mean like the thing from here to here. Is that
oh
correct?
yeah. Yeah.
So that would just be PS. Is that right?
Yeah.
Oh,
What's-
okay.
Good.
Yeah.
What's PS intersecting with RS?
Can you repeat the previous one, please?
The union of these two things is where the places where they're either one of them is. So it's this part plus this part. So it's PS.
And how do you draw that?
I did right here. I drew it.
Okay.
PR union RS. Just the two line segments together.
You're just including all the points in the one line.
Okay.
Oh,
Well, I'm not necessarily connecting the things. It just depends on which ones they tell me. Like if I said,
Right.
if they said OP RS, you know what I mean, there would be this part or that part. You know, all union means is or. So if you say PR or RS, another way to say that would be just PS. All right, what about the other one though? Part B.
It'd be PS and RS, so. Let's see. I'm trying to think about how you would write it.
Well, you gotta tell me what it means. Once you know what it means, then you'll know how to write it. PS
And RS.
and
Separate
RS.
them.
Oh. Okay.
Where's the part that these two things are intersecting?
P and S.
Nope. P's not on
Oh,
both of
where
them.
they intersect?
Yeah. It'd be from R to S.
Yeah.
The portion that's on both of them, right? And
Yeah.
means both.
Where they
This
both,
means either. Is that correct?
yeah, what's it? Yeah, where they both connect at one point.
Not necessarily where they both connect, just, well, yeah, that's fine. Where any of the points is on both of them. I like to say
Right,
it
where they
that way.
both like eventually all meet at one point. I get what you're saying.
But you should say that, that's the way that they usually say it. Though. They're just
Yeah.
like, where like one point is gonna be on both of the things. Does that make
Yeah,
sense?
yeah.
Okay. Any question with this?
No.
Measure of a complement of 61 degrees is, what would it be?
Supplementary? No. Complementary.
Yeah, what is the number though?
What do you mean? Like in a fraction?
They want the answer.
29.
29 is correct. 90 minus 61 is 29.
Oh, okay.
If you had something here and this was like 29, that would have to be 61 if this is a right
Right.
angle. What's the supplement of 86? What'd you say?
4?
Nope, not supplement.
94.
94 is correct. 180 minus 86 is 94. You gotta remember which one's which. Does that make sense?
Yeah.
No.
It-
Why are we using 180, but if it's 86, isn't it anything lower than 90 considered a complementary angle?
This didn't say complementary. It said supplement.
Oh, I totally skipped over that word.
Does that
I
make
was
sense?
just focused on the degree, yeah.
Okay. That's what I figured, but then
Yeah.
but
I was
okay,
just-
as long as you know which one, what each one
Yeah.
means, that's all. So like, if you wanna write an equation to do it though, which sometimes is necessary, all you would say is 86 plus what is gonna give you 180. And
Yeah.
then you just subtract 86 from both sides, so then you end up doing this.
I didn't even realize they were telling us the angle already there.
That's what honestly most of this is reading. Like I know
Yeah.
you know what most of it means. Find the value of x and then find the measure of each angle. All right, what would you say in this case? How would I do this one? Anybody have a suggestion?
Well, wouldn't you just add up both angles? And that would equal to 180?
Yes. So like this plus this, right? Whatever this angle is, I don't know, I'm gonna call it alpha. This one I'll call it beta. Like alpha plus beta is gonna have to equal to 180 degrees. So alpha in this case is 10x plus 7. Beta is 7x plus 3. And this has to give me 180. Okay, how do I solve this? First thing I always want to do whenever I see any type of equation,
Take the variables out.
say again.
Take the variables out.
The thing that people always say in math that like people kind of ignore all the time is like the word simplify. And all this means is just make it simpler because there's too much crap everywhere or there's too much stuff going on. So how to simplify this? Usually the first thing you always try to do to simplify anything is they say combine like terms.
Yeah.
So what do I mean by combine like the 10?
You would
And-
subtract 7x from 10 and then 7x from 7 also, and it would cancel out 7 and you get left with 3x.
Mm,
You can
No.
do is you can 10x plus 7x, and then you would combine 7 plus 3, and then you put 180 plus 10, and that you have 17x equals 10. So 170 divided by 17 would be
That's
10.
correct. That's correct. So the thing is that like, this is saying like, I mean, definitely for sure, there's no question that I think that if you have a 7 here and it says 7 plus 3, then that definitely can be replaced with 10. All right. So then this rest of this stuff here though, like 10x and 7x, by the same logic, like if you say like 10x plus 7x, like this can be thought of, I guess, also as 10 plus 7 x's, or in other words, this equals to really 10 plus 7 times x, or 17x. So all this is saying is like, if you have 10 of this thing, like in math, like x means it has to be the same, whatever it is. I don't know what it is, but it has to be the same. So this thing here and this thing here, whatever they are, they're the same. So I have 10 of these x's, and then I add 7 x's. Yeah, we got 17. Does that
Okay.
make sense?
Yeah, and the
Alright,
reason you
so
added
that's-
was because it called for adding, right?
It says adding here on the
Okay.
equation that we have, right?
Yeah.
Okay. So then this is, in other words, we have 17 x here. All right. And then what did you say? How did you get 170?
170 divided by 17.
No, not yet. What do you do?
Oh, I crossed over 10 to 180, so then it would, from adding it'd be subtracting, so it'd be 180 minus 10.
Right. You have to undo. Someone says that someone took 17 times some number and then they added 10 to it and then they got 180. Like adding 10 to it is just confusing. So just, you got to undo that. So if they added 10 to something and got 180, instead, if I subtract 10 from both sides, then really that would have to mean that the 17x would have to be 170.
Yeah.
Okay. So then we divide this by 17, I guess. Why do we divide this by 17 now? Because I have to undo multiplication here. 17 is being multiplied by x. So to undo that, just like we undid the addition, the subtraction, we'll undo this with division. So then x is 10. All right, so they said find the value of x, so we got 10. All right, now it says use that to find the measure of each of the angles. What's the answer for those? How much is alpha and how much is beta?
107 and 73.
Yep, so 10x plus 7. If x is 10, is 107.
Yeah.
And then if x is 10 in the other case, it's 73. And then we can check our answer because this has to add up to 180, and at least it does. Okay, question?
That makes sense now.
All right, he says name all pairs of vertical angles in this picture. So CVE is vertical with what angle? What is CBE vertical to?
DB.
DBA.
DBA, you need three letters. Does that make sense?
Yeah.
Hannah?
Oh, I don't care.
What else? What are two other vertical angles?
CBD and EBA.
CBD and EBA is correct. All right. I guess that was that. Well, see, shit. I don't know if they even thought of this, but this is, you could also start saying DBE and like DBE are vertical angles also, like this angle though and this angle. But I don't know if I really want to start saying that. Does that make sense? Like this angle and this angle are vertical,
Yeah.
Yeah, I understand. Yeah.
but I don't want to get it. I don't want to start saying that. Okay. So if X is 71, find the measures of angles 1 and 2. Okay? Can you explain me, please?
Wouldn't 2 be 71?
That's correct. 2 is 71. Why?
Then because they are vertical, or what's the word? I
Yep,
think
but
vertical angles.
vertical is correct. But I just want to make sure we remember what the words are because that's what they're gonna say on the test. So vertical, all right? Good though, okay? What else?
What is that? 109 then?
109 is correct. So
Okay.
then you said that these two guys here, that total measure would have to be 180. So therefore, angle 1 plus 71. Well, I guess we don't even need to, okay, I just did something I really shouldn't have done. So if they gave us 71 over here, we should start saying this and using, just in case we somehow made a mistake with this, even though we didn't, we should somehow use what was given to us, okay, to answer the question. So if this is 1 and this is X right here, so 71 is given to us then. So this is angle 1 plus 71 degrees, or angle X has to be 180. Therefore, angle 1 must be 180 minus 71,
Yeah.
which is 109 degrees. Okay. Any question? Not too bad, right?
Yeah.
Find the value of X and then find the measure of each angle. All right. So what equation would I write here?
How come the two given angles are different numbers if they're supposed to be vertical angles?
Mm,
They should be the same, no?
well, let's see. Let's do some math to see.
Okay.
You said they're equal. That's the part that really matters. So if some jackass wrote this symbol,
Oh, so we
Yeah.
just equal. Take that one equals that one, and we can solve that then.
exactly.
Okay.
So that's why I was like, you really did already say what we needed to do. So which is good. But the thing is then that's why I need to make sure the whole point of this is not really doing geometry. The point of this is to write an equation. Does that make sense?
Yeah.
Because if you can write the equation in this situation, maybe you'll be able to write it in the next situation, and then you'll actually be able to get yourself an answer to something. All right. So then, because otherwise it's, I mean, this is not even the craziest set of numbers here. And trying to do this, like without solving an equation to me, I don't know how I would do that. All right. So this, all right, how are we going to solve this? There's only like a couple of things I know about, like in solving equations. One of them is like simplify everything as much as you can, always make the number smaller and simpler. So that, you're not
36.
gonna make it. 36 is the answer for X. Is that what you're saying?
Yeah.
36 is correct. So the thing is here though, the way we end up solving any of these equations is, so I try to simplify over and over and over and over again at every step I do anything. And then the only other thing I really try to do is what they say is isolate the variable. So, and then how do you isolate the variable? You move stuff on each side. It's pretty much all you do. So you put the variable on one side. And the numbers on the other. Alright, so in this case here. I need to, I'd like to also try and keep everything positive. So right now, the way I consider this is actually. I think of everything merely being added, but this is. Like 5x is being added. Negative 129 is being added. 2x is being added on this side. And negative 21 is being added here. And then all I want to do is just undo this stuff to make it all on like one side. So what do I have to add here to get rid of the 129? I would add 129. So then add 129 to this, excuse me, get rid of the negative 129. So I would add 129. If I add 129 to the left side, then this part would be 0. 129 minus 21 is 108. How do you undo this 2x here? Or get rid of it so that it's gonna be on this side, so that I can combine it with the other x's and isolate the variables?
You saying how you cross over 2x to 5x?
Yeah.
If it goes, well, it's positive now. If it goes over, it's gonna be negative, so it'll be 5x minus 2, which is gonna be 3x.
Right, I just don't like the way you're saying it, because like, when you think of an equation, you should think of it like some sort of like scale, sort of. Like this
Mhm.
side's equal to this side, so like whatever crap they have lying on this side. You know, it's gonna equal the weight of the stuff on that side. If I decide to take this off of here, like I somehow have to like. Cut out part of that from there. You know what I'm saying? It's like the
Yeah.
same thing should happen to both sides somehow. So like if I decide to add 129 to the reason why, if I add 129 to this, these two things end up becoming 0. Does that make
Yeah.
sense? So
Yeah,
then
they
it's gonna
cancel each
go-
other out.
Right, they go away. So then if I add 129 to this side though, and I think of it like a scale, I gotta add 129 to this side. If I doesn't, then it doesn't matter what the next thing is. It's like if there's 2 x's here, you subtract those 2 x's and then you subtract the 2 x's. So then it's like 5 minus 2, you get 3, and then this is 3x is equal to 108. So then after that, now we just now have to again continue to isolate the variable. So then we get rid of this 3, it was multiplying, so that means we divide it out. So then this is x is equal to 36 is correct. Does that make sense?
Yeah.
Alright, so what is this one now?
Times 36. See.
51.
51, is it?
Yes.
Yeah, 51 is correct. So then this is 51 degrees. And then what is this one?
$51.
It better be, right?
Yeah. That was the whole assumption there.
Well, that's what if we did everything correctly here, then we would end up with the right thing. You know what I mean? But not necessarily, right? Question?
Nope.
Alright, 2 parallel lines cut by a transversal, same stuff we just said. I don't really want to do it again. Alright, what about these 2 things? Find the value of x and then the measure of each angle. Alright, so you just kind of got to remember like what types or which ones are the same crap. So like this one here is corresponding with this one and they're vertical. So that means these 2 things should be equal to each other. So 2x plus 61 should equal to 6x minus 51. Alright, what should I do to solve this? What do I do first? Hello?
Add 51 to both sides, like 51 to 50, so it cancels that out, and then 51 to 61.
Yep, that's good. So this would be 112. And then what else do I do?
You're
Would
gonna
you bring down
subtract
6x?
the 2.
Subtract the 2x is correct.
Yeah, that's
Because this is adding over here and I need to make sure that I'm gonna combine this with these. If you decide to move all the numbers to this side, you need to then subtract 2x. Does that make sense?
Yeah.
Alright, now what do I do?
You're gonna divide the 4 on both sides.
That's correct. So then this
So
is
what's
what,
gonna give you
4 goes
28?
into 28,
108.
right?
Oh, is it? I get.
4 goes into 125 and then 4 goes into 12 3 times. So it's 28. Does that make sense?
Yeah.
Question with this?
Oh, yes.
Alright, so if this is x, so x is 28. So what's this angle here then?
Came with 117, is that correct?
56 plus 61 is 117. 28 into this thing is 6 times 28 is 48. Carry the 4, so this is 12, 16, 168 minus 51 is 117.
Okay.
Any questions?
That clicks.
Alright. So simple can be drawn without lifting your pencil from the paper and without passing through the same point twice. So just like something that pretty much just starts and ends at the same place. Okay, that's referred to as, well, actually, excuse me. It does not have to necessarily start and end the same place. It just can't overlap on each other. So simple just means non-intersecting. A curve that doesn't intersect on itself. A closed curve has the same starting and ending points. All right, so closed means like this would be closed. Anytime you can draw it with that, where it starts and ends in the same place. So this would be simple and closed. This would be closed, but not simple. This would be neither closed. Wait, what?
Yeah, that one seems a little tricky.
It's not tricky, it's just wrong. Like this is, the way they've drawn this here, it's simple,
Yeah,
but not closed. It's not neither. That's not true. If you wanted to make something that's neither, then that would be more like that. That would
yeah,
be neither. Because this is still simple. It's not, simple just means it doesn't intersect on itself. Alright, so that was a little bit of an error, I guess. A polygon is a simple closed curve that's made up of straight line segments. It is regular if all sides are equal and all angles are equal. So this is referred to as an acute isosceles triangle. These two side lengths are the same here, so it's called isosceles. When something is isosceles also, these two angles are the same. I think that's something that's kind of like easy to say with triangles a little bit. It's like if the opposite side length, like tells me how big this angle has to be. So this opposite side length over here tells me how big this angle has to be, right?
yeah,
So if they're the same size, then like these angles have to be the same also. Does that make sense?
mm-hmm,
Alright, so obtuse scalene triangles. Why is it called obtuse? This angle right here has measure.
greater than 90.
Exactly. Greater than 90 and less than 180.
Yeah.
Right? So then this is called scalene. Scalene specifically means that no sides have the same length. So that would also mean automatically that all the angles would be different as well. So isosceles is two sides, exactly two sides, equal, are equal in length. All right, the sum of the interior angles of any triangle is 180 degrees. A quadrilateral has four sides and is classified based off its sides and angles. So these two things here are called quadrilaterals, as opposed to triangles. All right, parallelogram, what does this mean? What's a parallelogram?
And they're parallel to each other.
What's parallel to each other?
The top line and the bottom line.
Yeah, opposite side lanes. So like this side's parallel to this side,
Yeah.
and this side is parallel to this side. So the opposite sides are parallel, which would automatically then mean that since if I can consider this to be extended here, this angle and this angle would be the same, which would therefore mean that that angle would be the same also, which would mean that angle is the same. So the opposite angles are equal. All right, let's just make this chart about quadrilaterals real quick. We'll start going through all of them in a second, but quadrilaterals, trapezoids are like the weird types. This means exactly one pair of parallel lines. Then on this side, they start having a bunch of these. So parallelogram, this means, again, opposite sides are parallel. Quadrilateral just means four sides. Parallelograms, we can break, not necessarily break them down, but there's another more specific. So like what I'm trying to say with this diagram is that all trapezoids are quadrilaterals, all parallelograms are quadrilaterals. But then also like all rectangles are parallelograms.
What?
All rectangles are parallelograms. What's the definition of a rectangle? What's the definition of rectangle?
Two opposite sides the same length.
Okay, but not just that. Because like parallelogram, these two lines are the same length, but that's not a rectangle, right? Like the opposite side lengths are equal in this thing, right?
Okay. So they're the same length, right? The two opposite sides are the same length.
In a rectangle is true. What else? You need to tell me more. Because parallelogram already has opposite side lengths equal to each other. So really, we don't even need to mention that. So this is like opposite sides are parallel. That automatically implies that the opposite sides are equal. Does that make sense?
Mhm.
Right? I mean, you draw this and this, you draw that and that. If these are parallel, then this length and this length are the same. Is that correct?
Right.
All right, so that's not a rectangle. What's gonna make it a rectangle? If this stupid thing was going
Every
straight up
side
and
is
down,
90 degrees.
every angle, right?
Angle.
This means all angles are also 90 degrees. Is that correct,
Yeah.
Sarah?
Yes, sir. Yes.
So this one, the opposite side lengths are equal to each other. They're already parallel. And then in addition to that, all of these angles are 90 degrees. All right, then there's something called a rhombus.
Oh yeah, like the diamond.
It's like a diamond is correct. Do you know what it has to, what the characteristic I need for that though is? It's a specific type of like, when people say diamond, it's like kind of deceiving a little bit. Like, I don't know if they necessarily know what it means, but that's what everybody always thinks of though. So that you are thinking of the right shape. But the thing that I also need to say is, so not only, again, so all rhombus,
It's two acute
Oh.
angles.
no, it's that the side lengths all have to be equal.
Okay. Oh, that actually makes logical sense.
And then this and this are equal still, just because parallelogram has that property. Does that make sense?
Yeah.
Does it make sense, guys?
Yep.
All right, then there's one more. What's the last one? What's the last one? What happens if I draw a line that it's connecting from here to here? That means it has to have the properties of both of these two things. What has the properties of both of these two? What has all angles equal to
Square?
90? Square is correct. Square has all these properties now. All the angles are equal to 90 and all the side lengths are equal. And obviously a square has the opposite side lengths parallel to each other. Any question?
No.
All right, so this thing, he was saying solve this for X. So like whatever this thing is here, this plus all of this would have to give you 180. But this arrowed thing and this would also have to give you 180. So he's saying these two things have to equal to each other, which is true. So 3x plus 2x minus 5 equals to 3x plus 41. Does that make sense? Because he says any exterior angle has measure equal to the sum of the two opposite interior angles. So in a triangle, I don't even know what opposite angles means otherwise. Plus it's not correct. So like this angle here equals the sum of these two. Does it make sense why?
Can you explain, please?
If you have this like this angle plus this angle has to be 180, right?
Yeah,
This angle plus both of these has to also give you 180. Is that correct?
Yes.
So that means these two have to equal whatever this is. If this stuff adds to this and gives you 180, and this stuff adds to this and gives you 180, then this and this have to be the same. Is that correct?
Yeah.
So if we call this 1 and we call this 2 and we call this 3, angle 1 plus angle 2 must be angle 3 in terms of their measure. Okay. All right, convex just means that any line you draw through it has to be completely contained within the object. This thing is not considered to be convex because there exists a line that I draw through this where it actually ends up going outside of it. Does that make sense?
yeah.
All right, did somebody forget to ask a question? All right, what is this? Simple, closed, what would you say? Is it simple? Or is it closed, or is it both? Tell me for the first one. Let's call this A, B, C, D. Come on, people. What is it? Closed? No, because these points, because it doesn't go to the closed meant that it starts and ends at the same point. I can't draw this and then start and end at the exact same point. Does that make sense?
Pretty simple.
Yes.
It's not simple either. Simple means it's not intersecting. This is not simple. So it's actually neither simple nor closed.
Okay.
What's this one?
Neither. No,
This
closed.
one, this one, closed is correct. This one is closed. Does that make sense?
Yeah.
All right. What about this guy?
Both.
Closed?
Close.
Both is correct. It's definitely closed, but it's also simple because it doesn't intersect on itself. What about this thing?
Both.
They're both. simple
Both
and
is
closed?
correct. All right, now I guess let's add to this convex. Which one of the following things is convex? This one's not even like a closed figure. It can't be convex if it's not closed. So this one's
Mhm.
not convex. This thing is, when it's not simple, it's not really convex either because I can draw lines that would end up, well, actually, I don't know if you usually classify objects that aren't simple as convex or not, but this is not convex anyway because of something like that. Does that make sense?
Yeah,
So therefore, for the same reasoning, this one's not convex. What about this? Is this convex?
yes.
Yeah, this one's convex. Question?
I missed you when you taught convex. What is that?
That you draw a line segment on the inside of the objects. That's where one point is, where each endpoint is on the inside of the object. And if the line segment ends up going outside of the object anywhere, like this one does, then it's not convex. If all the line segments would stay inside the object, then it is convex. This one we would do that.
How is the object defined? Like, let's say first image.
Usually refer to convex in terms of polygons. I'm sure they're going to discuss things in terms of polygons. This is a polygon here. Polygon just means that it's a bunch of sides, but then it's actually closed and simple. So usually people would discuss it in terms of polygons. But really, you can discuss convexity in terms of anything. So now they bring up polygons. Does that make sense, Sarah?
Yeah,
Sarah?
No, no.
No? What doesn't make sense?
I don't understand what convex is.
That if you draw a line segment on the inside of the object, so in other words, between 2 points that are somewhere contained inside the object, that the line segment would be contained within the object always. That's referred to as convex. So this one is not convex. This one is convex.
Okay, got it. Thank you.
Also,
Okay.
like they'll say things like with like mirrors and stuff like that. Like if you have a mirror like this, honestly, I don't really remember which one is which. Because like, so like,
So
'cause, like
that-
these things, one of these,
convex then, because if you put it on the corners of those things, then you
this
want
one is
straight line.
not convex,
Yes.
right? But the thing is in terms of a polygon, okay? Now I just don't remember which one, what it means in terms of the thing I'm about to say. But like as a mirror also, it matters if these things are like convex or concave. Also as a lens for your glasses. So I don't remember which one's convex and which one's concave, because for mirrors and lenses is exactly opposite for each other. But the point that I'm trying to make is that like, depending on, you know, if I shot some sort of light or something and it bounced in here, it would like bounce over here somewhere. Whereas if you did it on this one, the light would bounce like away somewhere. So, and then if you shined a light through it, and then what would happen to it on the other side? You know, like these particular shapes end up mattering a lot in all different types of things. So they name it. Does that make sense?
Yes.
It's important to recognize the name of different polygons. Polygons have straight sides and are classified based off how many sides they have. Called polygon regular, it means all the sides have the same length. Also means all the angles have the same measure. All right. So I don't really like the way this is phrased. Regular specifically means has the same length and has the same measure. Okay. It doesn't, it's not this also means. Regular means it has to have the same for both of them. Because this kind of makes me think that if something has the same length, if they have the same lengths, that automatically they would have the same measure. And that's not true. We just saw that with a rhombus, right? Like the angles here are definitely not all the same. Does that make sense? So this is not called regular. So a regular triangle is called equilateral. What's all these angles here? Is this equilateral?
Yes.
Acute?
Acute. What's the number though?
What do you mean the number?
It's 90 degrees.
Nope.
On the inside, 180, right?
180 is the total measure on the inside. So what are all the angles?
Oh, 180 divided by 3.
60,
180.
60.
That's correct.
Yeah.
So then these guys are 60, all of them, right?
Yeah.
So the total measure in here is 180. Total measure in this thing is 360. Total measure in this one is, what's 180 plus that? What is that? 540. Total measure in this one is 720. Total measure in this one, they didn't draw 7. So this is 8. So it's 360 more. So this is 1080. This is 8 sides. This is 6 sides. This is 5 sides, 4 sides, 3 sides. If you want to say a formula for the total measure in this thing, it's the number of sides minus 2 times 180, where n is the number of sides. Therefore, if you want to determine what any of these angles are in here, it would be n minus 2 times 180 divided by n. Because, so for instance, like in this one here, 8 minus 6, excuse me, 8 minus 2 times 180, that's 6 times 180. That's what is it, 48, carry the 4, 100, Oh, it's not 1080. Wait, it should be 1080. Oh, because I just multiplied wrong. 6 times 8 is 48. Carry the 4 is 10. So this is 1080 here. So 1080, and then we're going to divide this by the number of side lanes here. So that's 8. So 8 goes into 10 one time, 2, 28 is left over. 8 goes into 28 3 times. Then 4 is left over. 8 goes into 45 times. So that's 135 degrees. So in other words, each of these angles is 135 degrees in an octagon. I don't think you really needed this formula to tell you that, because you could just draw a line. And then this is 90 degrees here. And then that would mean that this is 45. So 90 plus 45 is 135. But this is typically a formula that people will usually talk about. Like this is the total measure inside of a polygon. With n sides. And this is the measure of an angle in an n-sided polygon, n-sided regular polygon. Does that make sense? Any question here, guys?
Not for me.
So these are just names of these things: triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, and decagon. All right. That doesn't usually come up that much, the names. All right, we already talked about all this. Examples. Yeah, whatever. All right. Regular triangle. What's a regular triangle called? We just said this. What does regular mean first? Guys, what does regular mean?
All sides have the same length
And all angles.
and all angles.
Okay, so what's a regular triangle called?
Equilateral.
Equal lateral usually means a thing on the side. Does that make sense?
Yeah.
Like the lateral side of the boat. The port. Some lateral face. Some of the angles in a triangle, if you add them all up, you get 180. So find the measure of each angle in this triangle here. What equation would I write? I mean, you guys want me to just stop? Just tell you to do it by yourself.
Would that be the 2x minus 50 plus x minus 10 equals 180?
Nope. You
No?
forgot something. Close. You forgot one part. The sum of all of the angles inside the triangle gives you 180 degrees. So 2x minus 50 plus x minus 10 plus
X equals
X.
1. Yeah.
That's correct. All right, so now combine the x's here. So that would be 4x. Combine the numbers. That's minus 60. Now I guess we add 60.
And you divide 4 by 4x, and then
Divide by
by 240.
So then we would get 60. So what are all these things here? Well, this one's obviously 60. What's this?
50.
50. What's this
On
one?
the top.
What'd you say? 70 on the top?
Yeah.
Because what, 2 times 60 is 120, minus 50 is 70.
I guess
Yeah.
that's
In a triangle ABC, the angles A and B have the same measure, while the measure of angle C is 72 degrees larger than the measure of angles A and B. Then the measure of each of angle A and B. Oh, what are the measures of the 3 angles? All right, so I mean, I would draw a picture with this first. Not that it really makes that much difference, but let's say this is like 72 degrees. So then these two would actually have the same measure, which would mean these two side lanes must be the same, which means this is isosceles. So now he says, what are the measures of 3 angles? Well, I mean, this is kind of silly. Like they already told us C is 72, so I don't really need to worry about that so much. How am I gonna figure out what A and B are?
well 180 minus 72 divided by 2.
Yep. 180 minus 72 is what? 108. And then we should take that and split it amongst the 2 angles. So I guess we get 54 degrees. Is that right? Another way we could do it again is we could say that x plus 72 has to be 180. Therefore, 2x plus 72 is 180, or 2x is 108. So x is 52. 4. Stupid. Find the measure of each angle in triangle ABC. Well, we just did one pretty much like this. All I gotta do is add all this stuff up and set it equal to 180. So 5x plus x plus 4x minus 3 is 180. So then this is what, 9, 10x's minus 3 is 180. Is this right? Yeah. 10x is 183. So that means x is 18.3 after you divide by 10. Not 100% sure why he wants us to do this, but so then this one would be 5 times 18.3 It is 15, carry the 1 is 41, carry the 4 is 9. This is 91.5. 18.3 into this thing is 4 times 18 is 72. Times 1.3 is 73.2. Minus this is 70.2. And this is 18.3, I guess. But I would just do all that on my calculator. Question? Does it make sense?
Yeah.
Yes.
All right, what did we say about this thing? How we do something like this? Because evidently they're gonna ask you this. What did we say about this shape, how this works? Sarah, you made me write this out again. You said you didn't understand. before?
You want it to equal to 180?
180, something equals to. Well, what equals to 180? You're right.
Isn't that the 13x plus the 26x would be 180?
Mm-mm.
I keep making the same mistake. Okay, thank you.
Because look here, think of it this way, okay? Let's draw it with.
Oh, we have two angles already. We have 10x plus 15 plus 13x, and that would be 180.
Mm-mm. 3 angles have to add up to 180. All of them in the triangle have to add up to 180. That's a mistake you're making. Okay, but let me try and explain this a little bit more first. All right, so like if this is 1, 2, 3, and 4. All right, we know angle 1 plus angle 2 plus angle 3 is 180. Is that right? Right, guys?
Yes, yes.
Okay. Angle 3 and angle 4 is also 180, right?
Yes.
So that means 1 plus 2 plus 3
So
so that means then that if we start saying then
1 and 2 have to be equal to 4.
4.
that's correct. So then
Okay, let me.
1 plus 2 plus 3 is definitely going to equal to angle 3 plus angle 4. So therefore, if I subtract this from both sides, we would get 1 and 2 is going to equal to 4, right?
Yeah.
So what would I write here?
3 plus angle 4. So
So this one's called the exterior angle of 3.
angle 1.
What, and then these guys are all called interior. So all you gotta do is remember that you take the interior stuff.
15x.
And this one plus this one is gonna have to be equal to this one. So then this is gonna equal to 26. Does that make sense?
Yeah.
So X is 5 in this case. So that means this angle here is 65 degrees. This is 65 degrees. And then this is 130. Does that make sense, guys?
Yeah.
Yeah.
So what I have to do, what would the equation I would have to write for this one be?
Would it be 99x plus 2 equals 29x?
Nope. Can't say these two are equal to each other necessarily because I can't see if it's isosceles. Does that make sense?
So it's 99x plus
Yeah.
2 plus 29x equals 131x minus 1.
Perfect. 99x plus, so this angle and this angle have to equal to that angle. Does that make sense?
Yeah.
Shambria, was that you before?
Yes, I understand it.
So then this means this would have to equal to this guy. All right, now what should I do to solve this?
You add the, do you subtract the 29 from the 99?
No, you add them. This says add, right?
I mean, you add them both.
So then 99 and 29, that's like adding 30, so that's like 129, 128, right?
Mhm.
Plus 2. And this is 131. So then I'm gonna subtract,
For the 131.
because I want to keep it positive.
Yeah.
And then I want to add 1 also to get the 1 from that side. So we have 3 equals 3x. So that's easy. X is 1. So if x is 1, that means this is 101. This is 29. So that means this is 130. Is that okay?
Yeah.
Yes.
Any question? So you just got to remember that picture, because effectively it's going to be the same question every single time. All right, we went through all this. All right, a rhombus is an example of a regular hexagon. True or false? A regular polygon, excuse me. What do you say? Is this true or false?
False.
False is correct. Because rhombus, we said before, they don't have all the same angles. Is that right?
Mhm.
Yeah.
Yes.
All right. Square must be a rhombus. True or false?
False.
True.
Yeah. According to the rule right there, it should be true.
Because remember, all squares are rhombuses and all squares are rectangles, all squares are parallelograms, all squares are quadrilaterals. All rectangles are parallelograms and quadrilaterals, all rhombuses are parallelograms and quadrilaterals, parallelograms are quadrilaterals. Does that make sense? What's the definition of rhombus? Rhombus means all the side lengths are the same, right? So it says a square, a rhombus is a parallelogram having all equal length side lengths. So a square must be a rhombus. Yeah, squares all have all the same length also. Does that make sense?
Yes.
Yes.
Circles. Circles is a set of points in the plane that are equidistant from a fixed point called the center. A chord is a line segment having endpoints on the circle. So like QR is a chord, PQ is a chord, okay? An arc is formed by the endpoints of 2 chords. So like, well, it could be the endpoints of just 1 chord, I guess. So then like here, a chord passing through the center is referred to as a diameter. So this is referred to as circle O right here. So in other words, PQ is called a diameter. This, what is like PO called? Or OP, whichever. What's that called?
Is that the radius?
Radius is correct.
That's-
And don't forget that the radius times 2, then of course has to be equal to the length of the diameter, right? Right, because this side's also a radius, obviously. All right, so an angle with its vertex on the circle and sides intercepting the points on the circle is called inscribed in the circle. Anything that like all the points sit on the circle is referred to as inscribed. So like this angle here is called inscribed in the circle. Any question with this? What's the difference between a chord and a diameter? A diameter goes through the center. Does it even tell us what a secant is? Does anybody know what a secant line is? Secant line could also go outside of the circle. So it just means passes through the circle. Chord is inside the circle. Entirely. And the secant can leave the circle. Key. So now they start talking about similar triangles. So what do similar triangles mean? So they'll like in this figure here, so similar triangles of the same shape, corresponding angles are equal. So anytime you start saying anything similar, that means the angles are the same. So in this case, like J, S, R, we would say is similar to P, Q, R. And then not only does it mean that corresponding angles are equal, it also means corresponding side lengths are proportional. So like the picture I usually think of when I think of similar things or similar triangles is I usually think of some picture like this, where it's like if you took this two, like this triangle here, and then the big triangle, those things are similar to each other because it's like you sort of stretch the whole stupid thing out. So like you can always say like let's call this side length A, B, and C, and then let's call this big A, big B, and big C. So then what I could say is like A is to A as B is to B as C is to C. Because I sort of like where the top ones are from the small triangles and the bottom ones are from the big triangles. Because all I'm really doing is just like multiplying everything by some length, some number. Like, but every side length I'm multiplying it the same way. So that number would be whatever, more or less this fraction is. Does that make sense?
Yes.
So then name the corresponding angles and corresponding side pairs for this triangle here. So then what you would do is once you label it this way, what this means is like JS is similar to PQ. JS is similar to PQ. And then SR is similar to QR. And then JR is similar to PR. And you'll notice also that when I'm doing it this way, like the J is the thing that's on the outside, it's coming towards the center here. The P is the thing on the outside, it's coming towards the center here. And then, or not the center, excuse me, but like the same angle that has the appropriate corresponding measure. So we started off from the angles that has the 3 lines that are equal, and then we went to the ones that have the 1. So like this tells me that by just reading it. Find all unknown measures in the pair of triangles. Note that the triangles are not drawn to scale. All right, first, what's A here? How would I figure out A?
minus 180 minus everything inside.
Yep. So 180 minus 77 minus 45, I think that's 58.
Yes.
Okay. And then all you would say is because these things are similar to each other. I mean, they even labeled it for you. Like, I don't know. This is kind of stupid. So then this is 77. This is 45 because they said they're the same. And then automatically this would also have to be 58. Does that make sense?
Yeah.
All right, now let's talk about the other part where we say the corresponding parts are proportional, right? The side lanes. So what I meant by this is like, they multiplied this by 5. Does that make sense? If these things are said to be similar, then they multiplied this by 5, they would have to multiply this by 5. So therefore, this is gonna have to be 5. All right, first, when you're doing these problems, you have to show what's similar first. So how do we say these two things are similar? Well, because this third angle would automatically have to equal to this third angle here. So therefore, the two triangles must be similar because they have the same angles. Then what we want to do is write some sort of proportion. What do I mean by proportion? A over B equals to C over D, something like this, like two fractions. So in this case, like, this is the big one, this is the small one. Like, to me, I see that there's like 5 here. So I'm gonna do the big to small. So 15 is to 3 as X is to 1. And then 15 divided by 3 is 5. And then X is X, so we get 5. So either do it the way I said it first, which is like 15 divided by 3 is 5. So then 5 times 1 would give you 5 here. Or write it out with a proportion. Question? All right, how would I do this one? Number 4.
Everybody talking?
So would that be 21 divided by 14 is equal to, wait,
That's good. So wait, here, label it, call it the same way I was saying it before, like big and small or something like that, or A and B or whatever. So you just did 21 to 14. You took something from the big one and you were relating it to the small one, right?
Yeah. Well, that would,
So then take something again from the big one and relate it to something from the small one.
so it doesn't have a name, the thing with the 3 lines on the top.
We're talking about the side lengths. We're talking about the side lengths. So M is named right here. Right?
Oh, is that an M? Okay, yes, by 12.
Oh, okay. Sorry, got you. Thank you.
Yeah.
All right. So then, all right, so now we should simplify this. So 7 goes into both of these guys. So how about 3 and 2 instead? And now how do I solve this? There's 2 ways you can solve this. One way is to start saying that they multiplied by 6 here. So they would need to multiply by 6 there. So therefore, this should be 18. Or if we have M over 12 is equal to 3 over 2, then you need to undo the fact that they divided by 12 here. So multiply by 12. So this would cancel here. You would get M on this side. And then 12 cancels with 2, you get 6. 6 times 3 is 18. This is a terrible question. I again don't know if they want me to find. It's impossible to find the other side length. Because when it says find all the unknown side lanes, it's like, I would think you would need to find this also. But you can't, so. Anyway, he means unknown side lanes with a variable, okay? Any question with this last one? Guys?
No.
All right, this thing here, I'm just gonna do this one fast, I guess. So this is 300. So it's like the big triangle. I'm just gonna redraw the big triangle real quick. So this is 300 and this is X. And then there's this little triangle here where this is 100 and this is 50. Well, this angle is the same on both of them. They didn't really draw and tell me that they're similar. So I'm just gonna assume they are because there's no other way to do the question. But they should have told me that like, that these are somehow similar or something about this. Because you really shouldn't be assuming what I'm saying here. But there's no other way to do the question. It's in this similar triangle section, so it's gotta be this. So these angles are also the same. Because these two angles are also the same, that means these angles must be the same. So these two triangles are similar to each other. Now, if this length here is 300 and this is 100, then to go from here to here, you multiply by 3. So then to go from here to here, you should also multiply by 3. So we get 150. Any question?
No.
Either that, or you could say
Got it.
X is to 300 as 50 is to 100. This time now I'm doing big is to big as small is to small. Not that I have to do it this way, but I was just doing it this way. So this is 300. This part here is the same thing as 1/2. Multiply both sides by 300. And you would get X is 150. All right. Again, they didn't tell us these things are similar. These are really bad questions. Okay, so then this, we have to assume, again, these two things are similar to each other. So I'm going to assume that this length and this length are similar and that this length and this length are similar, okay? So I'm just gonna write what they should have written. So these two triangles, we should be saying are similar to each other, okay? Okay, so we gotta figure out all these side lanes. So I wanna figure out what A is. So I'm gonna say that A is to 8. No, excuse me. A is to 15 as what? What would I write on the other side?
A to 15 or 15 to 8 equals A to 10?
15 to 8 is,
As 8 to 10.
no, 15 to 8 should be 10 to A. But do the one I'm doing. I wanna do this one instead. A is to 15. So I'm taking this part from the big triangle, this part from the big triangle, then that would have to equal to what? This part from the small triangle to this part from the small triangle. 8 to 10. Is that correct? Sarah?
Yes, okay.
So then this cancels with this, we get 4 and 5. And then I can, I guess, multiply both sides by 15. And then we would get A is equal to 15 cancels with 5, you get 3. So this would be 12. And then we can write almost the exact same equation with the B and the 6 now. So B is to 15. Did you want me to do it a different way, or you want me to do it the same way?
Wait a second. It's fine. It's okay.
So B is to 15, because it doesn't matter which combination you pick as long as it's the same relationship on both sides. Does that make sense?
Yes.
So that's why I'm trying to do different ones. So B over 15 is equal to what? What would I say?
6 over 8.
6 over 10. The 15 is the hypotenuse, right? The 10.
They're opposites. Yeah.
Okay, so B, right, because they're flipped around. Like
Yes.
another thing that's kind of helpful is to like redraw the stupid picture. Because like when it says this, I should have done that honestly at the beginning. This is 15, this is A, this is B, and then this is like, I kind of would rather see it like this. Like 10, 8, and 6, because then it's like clear what's corresponding. Does that make
Yes.
sense?
Yes, that's why I was getting confused. Okay, thank
So
you.
15 is to B, or excuse me, B is to 15 and 6 is to 10. So this means this is the same thing as 3 over 5 when we cancel these guys. Divide by 2, divide by 2. Multiply by 15, so you get B is equal to 3 over 5 times 15. So we get 9. Any question? Does it make sense, guys?
Yes.
Alright, this is the same thing. I don't want to do it again. Solve the problem, a waffle recipe that serves 7 calls for 1.5 cups of flour. How many cups of flour will be needed if the chef must serve 35 people? Alright, I'm glad he's drawing a picture here and stuff like that, and that's wonderful and stuff. But you don't have to know how to graph shit in this class, so forget this garbage. So the a waffle that serves 7 calls for 1.5 cups of flour. How many cups of flour will be needed if the chef serves 35 people? Okay, fine. So 1.5 cups is to 7 as the number of cups we're looking for, let's call that X, is to 35. Does that make sense? Does it make sense, guys? Yes or no?
Yes.
Another way you could just say it is like they're multiplying this by 5, so all we should do is multiply this by 5. Is that correct? So multiply this by 35 over here, 35 over there, 35 cancels with 7, we get 5. That's why I'm saying 5 times this. 1 point, so 1 and 1/2 is the same thing as 3 over 2. So this is 15 over 2 or 7.5. So 7.5 cups or something. Does it make sense what I'm doing here? Anybody still here?
Yes.
Pythagorean theorem relates the lengths of the legs of a right triangle to the length of the hypotenuse. Legs of a right triangle on the two sides which make a right angle. The hypotenuse of a right triangle is the side which is opposite the right angle, the bigger one.
Wait, Professor, what was the answer for the previous question? I was trying to figure it out.
7.5.
Okay, thank you.
Now the interesting thing about the Pythagorean theorem is it says if triangle ABC is a right triangle with measure of angle C equal to 90 degrees, then this implies that A squared plus B squared is equal to C squared, where anytime we draw a triangle, like if they label this capitals, the opposite side lengths are labeled as lowercase. Okay, so in this case, when I'm talking about a right triangle, and I say C is this angle here, automatically the hypotenuse is the thing on the other side. So the reason why I say this is kind of interesting is because, like, if you call this statement P and you call this statement Q, P implies Q is true with the Pythagorean theorem, but also Q implies P. So the Pythagorean theorem and the converse of the Pythagorean theorem are actually true. Okay. Oh, I didn't know this Pythagorean triple. Oh. Okay. If we call these legs of the triangle A and B and the hypotenuse C, then A squared plus B squared equals C squared. Find all the unknown lengths of the sides. So in this case here, what I need to do is use my formula. Since this is a right triangle, C squared is equal to B squared plus A squared. So C squared is 85 squared. B squared is 84 squared. And then we have to try and solve for A squared here. So I guess it's time for the calculator. 85 squared is 7,225. 84 squared is 7,056. So this thing taken away from 7,225 is 169, it seems. So how do I solve this now?
The opposite of exponent, I don't know what that is.
Well, that's a good point. But
What
it's
is
the root.
root?
So like if they start saying this, right, then we write the third root. Does that make sense? So then if you do this one, you take the square root. So you would say this is 13. All right. And that's usually just a symbol on the calculator. So it's like 169 is here. And then let me see if I can zoom in a little here. This one is square root, and that's it, 13. Says for any integer greater than 1, this is a Pythagorean triple. Find the triple generated when n is equal to 5. All that means is just plug in 5 here. So this is 10. 5 is 25 minus 1 is 24. 25 plus 1 is 26. So that's all they're saying. This is a Pythagorean triple. In other words, 10 squared plus 24 squared gives you 26 squared. Question here?
No.
All right, perimeter and area. The perimeter of the polygon is the sum of the measures of the lengths of the line segments that form its sides. The perimeter is measured in linear units or just units. The measure of a circle is called its circumference. The perimeter of a circle is called its circumference, excuse me. So for instance, like if we have a rectangle, then this side length and this side length would have to be the same. This side length and this side length would have to be the same. So like the perimeter of this object would be like W plus L plus W plus L, or 2W plus 2L. Any question with that? But the perimeter of a circle, they call it the circumference. Does anybody know the formula? So what you can say is, you can say that all circles are they're similar to each other because they have the same angle. So they're both 360 degrees. So they both have the exact same angle. So what that means is the corresponding parts have to be also related to each other. So if I consider the center, and then I call this thing here the diameter, little d, and then I call this one here the diameter, big D, then if this is little c and big C here, then the big circumference to the big diameter must equal to the little circumference to the little diameter, because these two things are similar to each other. And then in that value is kind of special because like, I don't know, how many times do you think it takes for the diameter? If I took something like a string as long as the diameter, how many times do you think it would take for it to go all the way around the circle? Like all the way from here to here, from there to there, you know, whatever. How far do you think it would take? Like how many diameters fit into the circumference?
Maybe 4.
I would say something like that. It turns out it's about 3.14 blah, 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 blah,
3.
pi. Does that make sense? Pi many times, the diameter will fit into the circumference. So then we could say that the formula then is the circumference is equal to pi times the diameter. Or sometimes people write it with the radius, and then they start writing that the diameter is 2 times the radius. So it could be also written as 2 pi r. Does that make sense? Okay, it says the perimeter of an equilateral triangle with side length equal to blah, blah, blah is the same as the perimeter of a rectangle with side lengths 15 and 12. All right, if a rectangle has side lengths 15 and 12, then that means it's 30 plus 24 is 54 is the perimeter. So then if an equilateral triangle needs to have that same perimeter, this should be 54 divided by 3 or 18. All right, now they start writing all these equations here. I guess they expect you to know all of these. So let's go through them. So the perimeter of a triangle is A plus B plus C. I think that's easy. The perimeter of a rectangle is L plus W plus W, or 2L plus 2W. The perimeter of a square is 4 times the side length, because all the side lengths are the same. All right, what's the difference between perimeter and area? So like, if you talk about a rectangle, and I say to you, how much, like, what is the length that goes around the outside here? Fine, let's say that's measured in like meters. But if I start asking you how much space there is on the inside, then that's referred to as area. So how many of these 1 by 1 squares would be in there? If this is 1 meter by 1 meter, then this we say is 1 square meter of area. So then I would count how many of these there are. 1, 2, 3, 4, 5, 6 times 3. Does that make sense? So if this is the length and this is the width, then the area of this thing must be the width based off the number of units that it is times the length based off whatever units it is. And then that means it would be length times width, but then it would be units squared. So that's why like they'll say square feet when you're buying carpet or something like that, you know, and because that's the amount of area that it's actually taking up. Now, you're not really supposed to have to memorize all these formulas. Because like there's an easy way to remember all of them. So if you think about a parallelogram, like a parallelogram is really just a rectangle. But someone like chopped this part off right here and moved it over there. So the rectangle and the parallelogram end up having the exact same area. So for some reason, they start calling it a different name. So they start calling this the base and this the height. But the area of the rectangle is the length times the width, which is really the same thing in this case as saying base times height, which means then the area of the parallelogram would also have to be just base times height. So that one's pretty easy. Then if you want to say a triangle, like a triangle is just half of a parallelogram. So the area of the triangle is 1/2 base times height. Does that make sense?
Yes.
How do you define the height? Where is the height? In the middle?
Depends on how you draw it, really. So
That would be a given.
like try to always draw the triangle where one of the side lengths is like flat. And then if it's just normal like this, then the height is drawn
In the middle.
perpendicular, okay? If the only weird way that usually it starts happening is like when it starts looking like this, I guess. Now I have to kind of draw this down here. And then this distance from here to here is the height. Does that make sense? Because
Oh.
try and think of it, another way you can think about it also is like try and finish off where the parallelogram is.
Okay.
Does that make sense?
Yes.
Because then this is the base and then the height would be like that length. So I guess it's that. Okay.
Okay.
All right, so then triangle is 1/2 base times height, rectangle is length times width, square then is also length times width, but now they're just calling them both S. So it's S times S. S times S would be S squared. This is base times height, and now a trapezoid. So like if you draw a trapezoid like this, and then he's saying, he's calling this B and then this B and then this H. It makes more sense why he's calling this H when he draws it this way. But if I draw a trapezoid like this, then the way you can think about the area of the trapezoid is you could say that if I draw a rectangle here, and then make it so that like this area and this area are the exact same thing. So make so that this height here or this length or whatever, it ends up being the exact same thing. Those two triangles. Then what that would mean is that I took away the area from this one and added it to that side. The area of this rectangle would be the same thing as the area of the trapezoid. So the area of the trapezoid in this case has to equal to the same thing as the area of the rectangle that I've drawn. And then that rectangle that I've drawn is like length times height. Or let's write it the same way he's writing it. H times L. Now L, what I could say L means is L is exactly the average of these two lengths. Like if this one's 5 and this one's 7, then this has to be 6. Does that make sense?
Yes.
So then this is going to be H times, how do you find the average of two numbers? That's just, you add them up and divide by how many there are. So there's two numbers here. So there's going to be B plus B divided by 2. And then he just moved the 2 around. So he moved it over here. Now, I like saying it this way though. Average of the bases times the height. Any question? If the area of a certain triangle is 48 and the base measures 8, then the height must be 12. If the area is 1/2 the base times the height for a triangle, so pretty much you just use the formula to start plugging everything in. So it says the area is 48, so this is 48. 1/2, the base it tells you is 8, so that's 8. H, we don't know. So now we simplify this. 1/2 times 8 is 4. So 4H is 48. So H is 12. All right, what's the area in the perimeter of this thing?
What is a yard?
Good question. 1 yard is 3 feet. So I would just say this is 6 feet. Does that make sense?
Yeah.
So the perimeter is 6 plus 6 plus 6 plus 6, right?
That's correct.
Be
So
20,
it would be 24 is correct.
and then your area would be 36 square.
That's correct. Now I want to make sure you also say it with the units, okay? So you should say this is either 36 feet squared or 36 square feet, okay? All right, perimeter and area of this one. He says this is isosceles. Of course, they really should tell you which side lanes are the same, but I guess I'm supposed to infer from the picture. So this is 30 to 9.7 there. So that means the perimeter would just be 39.7 plus 39.7 plus 23. I think that's easy enough. The area is 1/2 base times height. So that's 1/2 23 times 38. Okay. So this is what, 19? That's 23 times 20 minus 1 is 460 minus 23 is 4, was it 60 is 40 is 37 millimeters square. Tell me if you guys have any question, because this is just really just plugging in the formulas now. Does it make sense?
Yes.
How would you do this last one?
Are 38 yards?
Mm-hmm.
I times 38 yards.
What do you mean?
I times 38 yards.
Close. The only thing is so the reason why I'm asking this is really easy to make a mistake. Like this is the radius, and this is now the diameter. you first need to figure out what the radius is. What would the radius be in this one?
Half of 38.
Exactly. So this is 19. Does that make sense?
Yeah.
Yes.
So then C is gonna be 2 pi times 19, which really is 38 times pi, right? And then in this case here, I don't use 38, I need to use 19. So A is gonna equal to pi times 19 squared, which is 361, I think. Does that make sense? Guys? Hello?
We are tired, Professor.
I agree, but we gotta finish. How many more are there? There's still a few more. All right, a stained glass window in the church is in the shape of a rhombus. The perimeter of the rhombus is 8 times the length of a side in meters, decreased by 32. Find the length of this thing. So rhombus, you have to remember that all the sides are the same. So 4 times the side length is the perimeter. And then it says the perimeter of a rhombus is also equal to 8 times the length of the side minus 32, or decreased by 32. And it says find the side of the window. So then this would mean then I need to solve this equation, I guess. So then subtract 4s, add 32. You would get s is 8. All right, I at least want to do all these questions on the video so that you guys have it. If you guys want to go, you're certainly allowed to go. All right, I'll put the video online for you. All right.
So you
All
put,
right, cool.
so it would be 4S. That one I
Because
can get.
because the perimeter for the rhombus would be like s plus s plus s plus s. Does that make sense?
Mhm.
So then they're saying the perimeter. So anytime you have one of these questions like this, you want to try and read the sentence and then convert it to some sort of equation. So the perimeter blah, blah, blah is really just means equals. So perimeter is 8 times the length of a side decreased by 32 minus 32. So then I don't know what the perimeter is. So then I just start saying the side length is s. So therefore it needs 4s has to be equal to 8s minus 32. Does that make sense?
Yes.
All right. A lot is in the shape of a triangle. One side is 300 feet longer than the shortest side, while the third side is 500 feet longer than the shortest side. Okay, whatever. So there's some shortest side, something else is bigger than that by 300, and something else is bigger than the shorter one by 500. The perimeter of the lot is 3,500. Find the length of the sides. All right. If you do this, I think it's not that bad. If you don't, I think it's going to be confusing. But if you do this, then all I have to do is just add up all the side lengths now. So x plus 300 plus x plus 500 has to be 3,500 because these are the different side lengths that we have now. So then we combine like terms here. 3x plus 800 because x plus x plus x, and then 300 plus 500. So that should be 3,500. Then get rid of the 800. then this would be, I guess, 2,700. And then divide by 3. So we get 900. Now, this is something I would always screw up also, because I would always be like, okay, I'm done. Goodbye. And don't forget to answer what they want. Find the lengths of the sides. So this one would be 900, I guess. This is 1,200. And this is 1,400. Any question on this one?
No.
The survey plat, I don't know what a plat is. In the figure shows 2 lots that form a trapezoid. All right, whatever. The measures of the parallel sides are 114.40 and 174.0. Sure. 114.40. Sure. The height of the trapezoid is 165.41. Find the combined area of the 2 lots. Okay, whatever. So all this really just means is find the area of the trapezoid. So really you just have to remember the area formula, which is kind of annoying. But 1/2 times the sum of the bases. In other words, this is the average of the bases. You have to know what basis means, okay? So they drew it like the wrong way. The bases are this one and this one. So it really means this one and this one in this case. That's where people usually make the biggest mistake. Then the height, once you know where the bases are, I think the height's not that bad. The height is, you know, like the distance from there to there when drawn in some sort of perpendicular fashion. So that this would be the height in this case. So in other words, the average of the bases times the height. So this is 1/2 times B1 plus B2 is 174 plus 114.40. And then H in this case is 165.41. And then really this is just doing this on your calculator. I would do this part first though, on the calculator. Does it make sense, guys?
How did you decide which one is the base?
So
what-
you gotta remember the original picture, really. So like, they're. When they draw a trapezoid, the base is the thing that's lying down. This is the way they draw the trapezoid. So that means they're calling this thing a base. But then this thing is sort of a base also, because like, what if I drew it like this? Does that make sense?
Yes, that's what I would consider the base, so I don't see it in the other picture.
Well, I mean, if I turn the stupid thing, right? How do we do this on this? Can I do it on here? I don't think I can with this program. Can you order rotate each can? Rotate 90 degrees. All right, so if I draw this way now, right? These are still the bases. It's not like the name changes just because of the way you drew it. Does that make sense?
Yeah.
Sarah?
Yes, but how would I know that that's what happened?
That is what happened. That's what you have to be able to say that. That's the whole point. So you have to just redraw it and redraw it in the correct orientation. So in other words, turn this again like that way. Does that make sense?
How would I know which way to draw it?
You have to try and think about that. Try and move it around and try and make it look in the same orientation as the other one so you can match everything up.
Okay.
All right. Because if I say anything more than that, like people try and find rules to doing everything. Like, oh, what do I do if it's like this? What do I do if it's like this? What do I do if it's like that? That's not good. That makes like 750,000 questions in your head, and each one has a different process to get the answer. And that's like impossible to remember. You know what I'm saying? So if I just say something like match it up with the other one, then you could do that in lots and lots and lots of different cases. And it's not just like the one way. I don't know if that makes any sense what I'm saying.
So I have to match it to my imaginary trapezoid.
Correct. That's honestly perfect. So like they write this nonsense, they're calling this height. To me, it looks like a height right now. To me, this looks like a base. Does that make sense?
Oh, yeah.
So you got to draw it in that same orientation. All right. Like the two parallel sides are the bases. Is that right?
Yeah. That's good.
But
Yeah.
I think you should be able to say that just by thinking about the way it looks. Does that make sense?
Yeah, what you said now is the perfect solution for me. The two parallel lines are the bases. That's perfect. Okay, got it. Thank you.
The circle has a circumference of 75.36. Use 3.14 to approximate pi. Find the value of x. Oh, and they have to do x plus 5 also. Okay, whatever. So the circumference formula is 2 pi times the radius. The only thing is the radius in this case is x plus 5. So C is 75.36. This is 2 times pi times x plus 5, right? So then I guess we should, to isolate x, I first want to get rid of all of this stuff. And then if I were you, I would just do this on my calculator first, if these people picked reasonable numbers. 75.36 divided by 2 divided by 3.14. Good, it's 12. So this divided by this is 12. And then we would just subtract 5, and then we would get x is 7. And they didn't provide us any units, but you really should say that x is 7 units. You shouldn't really write that it has no units. We don't know what the units are, so we just write units. Does this make sense? This question was kind of hard.
Yes,
Make sense?
yeah.
Suppose carpet for a 10 by 12 room costs 300. Find the cost of carpet a room 40 by 48. I would set up a proportion. All right. So I would say like dollars is to square feet. For one room as it is to the other room. So in other words, this would be like $300 is to the number of square feet here. So that's 10 by 12. So that's 120 square feet. Does that make sense? And that has to be equal to what for the other room?
X divided by 40 by 48.
Very good. X divided by 40 by 48. And honestly, if I leave it as 40 by 48, it'll be easier for me to figure this out. So I'm going to leave it that way. So 10 times 12. So now I'm going to multiply by 40. And then I'm going to multiply by 40. But 40 cancels with 10 and gives me 4. Then I'm also going to multiply by 48. And multiply by 48. But 48 cancels with 12 and gives me 4. So then we would be left with X is equal to 4 times 4 times 300, which 4 times 4 is 16 times 3 is 48. So this is $4,800. Does that make sense?
Oh, you did 16 times 300 and you got 400, 4,800, right?
Yeah, because effectively, like what you could say is like, I want to find out how much times bigger this room is than this room, right?
Yeah.
So then all I'm really saying is like 40 times 48 divided by 10 times 12. So that's 4, and this is 4. So that's 16. That should be, so this is like the big room to the small room in square feet. And then that should be equal to the big room to the small room in dollars. So the big room, we don't know, the small room is 300. So 300 times 16 gives you 4,800.
Okay.
How would you find the area of this? What they want you to try and do with these types of questions now is remove some area from some part to figure it out. So like, if we think of like the big giant rectangle here, and then we subtract the areas of these two triangles, we should be able to figure out the right thing. So in other words, the top part is 82 centimeters. This part is 66 centimeters. So the area of the big rectangle is 82 by 66. And then the area of these triangles, well, the area of a triangle is 1/2 of base times height. So the base here is 41 and the height is 26. So this is 1/2 times base is 41, height is 26. So that's 13 times 41. So that's 52 plus 520 plus 13 is 533, I think. Let me just make sure that's right. 0.5 times 41 times 26er. 533. Okay, good. 82 times 66 is that thing. 5412 minus 533 is 4879. And this would be centimeters squared. But do you understand what I'm saying by the subtraction part here?
Yes.
Like removing this and this. Okay, sorry. The reason why I was a little worried about this is because like we still have an entire other section we're supposed to do. And you know, this test is supposed to be next week. So I'm a little worried to finish this. Okay. I was intending on actually finishing all of this in one day, but I went slower than I usually go, I guess. So so I guess we'll finish up the remaining section on next time. Please also bring questions from any of these things. I know we had to go through a few of these things at the end, and obviously it's really tiring. But you know, if you have any questions, just let me know, and you know, I can meet up with you, or we can talk about it again next time. Okay,
Yes.
Yeah,
Yeah.
thank you.
sorry, guys. If anybody has any question now, also, we can go over anything you want now as well. Otherwise, have a good evening.
Thank you.
How are you doing, Professor?
Thank you.